actually. The
I can
LCDs.
tell in real overcast days when I'm looking at like a white screen versus like a dark screen. It's like my face just lights up, and I'm like, oh, I'm too close to my monitor. But we'll go ahead and kick this off. I want to say thanks to the sponsors, Source Allies, Growers Edge, Lean Techniques, and Lozano Tech for sponsoring this event. And we'll go ahead and I'll add people as they join. If you want to introduce yourself, Dwayne, and your topic, and we'll go from there.
Sounds good. Yeah, thanks to all the sponsors. Thanks, Alec, for having me. Really great to be part of this Midwest Global AI Developer Days. So we're going to talk about responsible AI and data for public health and law enforcement. Also going to add a little bit of additional in terms of closing the skills gap with machine learning technologies as well. Um, done this talk before. I've done both of these talks before, and I've kind of merged two talks together just to provide a little bit of extra time because the one talk's only about 30 minutes, so give it a little bit more time in there. But yeah, welcome everybody. My name's Dwayne Natwick. I'm global cloud security lead for Atos, a global systems integrator that we provide managed security services and security consulting to companies around the world. Um, I am also a Microsoft Azure MVP. Have lots of years of experience and lots of certifications. You can follow me on social media. I'm also an author. I've authored three exam guide books. The third one is currently in post production to be published hopefully before the end of the year. So really excited about that. All around the security, we've got the fundamentals of security, we got identity and access, and we've got the cybersecurity architecture to just round off the entire uh, step through approach of certifications and security. But let's what we're going to talk about here today is I'm going to go through some general concepts around data and AI. So be a little bit of fundamental knowledge. We'll talk about data ingestion and then how we can take that data and ingest that and model it and analyze that data, and what some of those examples around how data modeling and AI are used within law enforcement and healthcare, and some of the things you have to take into consideration in those in terms of being responsible with AI, and then we'll close it out by talking about some ways that machine learning and AI can be used for security and governance, and some of Microsoft solutions around that as well. Let's talk about some general concepts here. Uh, we're dealing with a data abundance, and everybody probably knows that. We've got data flowing from everywhere. We've got so many attached devices today. I have probably 10 times more attached devices in my own house than people that live in the house. Just when we talk about Echo device, the Echo devices, your smart televisions, your mobile devices, your laptops, your desktops. I think I've got 6 connected devices just sitting in front of me right now. So with all of those comes data, and what we do with that data, how we protect that data, and when we get into the business world and we start utilizing things like connected thermostats and video surveillance technologies, that's also streaming data into data sources and data devices. So what do we do, and how do we handle those, and what can we do to continue to utilize that information and work with that information from an analytics standpoint? And that's where really data and AI really merge. But the thing is where's that data all coming from, and where's that data stored? What do we do with that data, and how do we manage that data? How do we govern that data? And knowing your data and knowing what your data is, and classifying all of that data that comes in becomes a real challenge, especially if you're in some sort of public service service environment where you have customers, or you have healthcare information, you have personal identifiable information. You need to keep that protected, keep that and manage that and govern that and maintain custodianship of that data. And there's the traditional way that we load data, in terms of grabbing that data, really from a batch standpoint. You then transform that data and you load that data. But what we want is immediate information, immediate data, immediate dashboard graphing that we can identify what is in that data. And that could be even from a law enforcement perspective, what we have in terms of you know of investigative information, and how we can find somebody that has committed a crime on a video surveillance. We don't have time to just bring that data in and create some level of transformation. We want that going right into a dashboard. We want that to be alerted, and we want to know and identify, maybe from multiple data sources, find a path that person is traveling and things like that. So it gives the ELT, the extract, load, and transform process, gives us that capability, because it doesn't have to be fully transformed. It doesn't have to be in a pristine form. It takes that raw data and it manipulates it in a way that can be used, and allows us to use that data for multiple uses as well. So maybe it's not just for the initial identification and path of a person that has committed a crime. Maybe later on it's being used for driving the evidence that is used in court. So all of that extract, load, and transform is how we're dealing with that streaming data today, to utilize it in many different ways. And how are we using that data, and what are we doing with that data? We rely a lot on the data science and and putting mathematical techniques and statistical techniques to analyze that data, and then running it through modeling, machine learning modeling, and then using some form of artificial intelligence, software and apps and agents that can help us uh, to analyze that data, as well as to utilize that data in some intellectual way, an intelligent way, and maybe even an automated way that is more efficient than we can do with our human resources and our own naked eye. And when we're talking about artificial intelligence, what we're talking about is software that has human-like abilities. And I think Alec was saying that there were already some presentation about some ways that we can utilize bots and things like that. We utilize bots on a regular basis on websites. I probably go on at least one website a day that all of a sudden a chat screen pops up and say, "Hey, can I help you with anything?" Well, that's a bot. And the intelligence on those bots, do levels of visual analysis, text analysis, can do text to speech, speech to text, and then does some level of decision making at times. So being able to find a flight for you and book a flight. It's also utilized a lot in terms of the ability to analyze viruses for vaccines, or analyze and do modeling on certain diseases, on modeling and analyzing, like as I've said before, paths that a potential theft has happened, a potential somebody that's potentially broken the law, finding that path that person is taking. However, there are challenges, and one of the things that I always say about AI and ML is that the utilization of machine learning, and especially the utilization of artificial intelligence, is exactly that. It is artificial intelligence. It exhibits human-like ability, but it's not human, and it has its flaws. And those flaws generally are brought on by by the people that develop that particular artificial intelligence. So, we need to make sure that we are in tune and we are thinking about, and we have different areas of gender and race and ethnicities and different countries represented, if you're using something that's going to be global, to avoid biases of that artificial intelligence. um, Understand that errors in that artificial intelligence may cause harm as well. If we have an autonomous vehicle, self-driving vehicle, and the system fails, or the artificial intelligence and the sensors aren't reacting in time, there could be a collision. There could be, you could run into a tree. Lots of different things that could happen. Very important thing, data could be exposed. Again, we have all of this data that's being ingested, whether it is personal identifiable information, whether it's health information, whether it's just raw sensor data. We need to know what all that data is, where it's coming from, where it's going, where it's residing, and making sure it's protected. Maybe make sure it's going across protected circuits, that it's encrypted in transit, and then when it's being stored, it's encrypted at rest as well. uh, the solution may not, there may be situations where solutions may not work for everyone. We need to have accessibility for the hearing or visually impaired. Users must be able to, there must be trust and within those systems. If they're very complex, what are they based on? And we should have transparency from that standpoint, and who's liable in those decisions. And what, there's a problem if there is in the chain of custody for crime. And this is something that has been a consistent issue and consistent discussion around law enforcement, is should we be able to use facial recognition on surveillance cameras, because they have found situations where potentially that facial recognition has not modeled that person correctly, and an innocent person has gotten uh, gotten charged for a crime that they didn't commit. And we need to make sure uh, that we have that level of trust, and we have a chain of liability if for some reason those systems fail. And this kind of then moves into some of the things, that the principles of responsible AI, that I've been kind of saying. It needs to be fair. There shouldn't be any bias. It needs to be safe. We need to make sure that those issues, in terms of, like, for example, the autonomous vehicle, or even potentially misinterpreting somebody's facial recognition, that there's reliability there. Privacy and security of the utmost importance when we're talking about somebody's data and somebody's personal information, somebody's facial recognition. I'll give an example. To this day, I don't know if my daughter has changed on this, but my wife will not use facial recognition on her iPhone. She's like, I don't want my iPhone to know who I am. And yet, I'm like, I kind of say, well, go to your photos, and your iPhone already knows who you are, because your photos are all organizing albums based on, here you are, and here are your kids. Anyway, so using facial recognition on your phone, it's not that big of a deal. But there is that piece and that challenge of trust right there, of not trusting that technology. Inclusiveness, again, that goes right along with fairness, that it should, not only should not have bias based on gender or race or ethnicity, or country of origin. It should also be inclusive for those that might have certain impairments. They might, it can't be something that they can't use that technology if they're visually impaired, or if they are hearing impaired. That there is some level of accessibility and inclusiveness on that. Transparency, having full transparency. Again, that's back to the level of trust and liability. There should be it should be documented, what the entire process of data handling, of modeling, of what technologies are being used, and then the accountability of this is who's responsible for it as well, becomes very important, and those two really tie very closely together. So let's talk a little bit about that data ingestion and where that data is coming from. Obviously, the main reason why we're ingesting data from all of these locations, it's changed a lot in terms of, or maybe not changed a lot, but we have so much data that we can use today. Data is growing, at an increasingly exponential rate, much higher rate than 5 years ago it was even predicted to grow. So, and that goes to on the fact that we have created this environment where we have so many connected devices that are gathering data on a constant basis. I don't know how many of you open up a social media account and just so happen to have an ad from something you just talked to your wife or life partner or girlfriend or boyfriend or whatever about, in your phone, in your feed. And you're like, hey, I don't have my mic turned on. I have my mic turned off for this particular application. And that's something that, is always, some people feel a little bit violated and invaded by that taking place. And it was something that some of the social media platforms were really under fire about. One of them decided they were just going to start doing a commercial about how great it was that they're hearing all of your information, and you can leave it to your own accord to find out who I'm speaking of. But even so, there's a lot of data coming in. It's coming in from the hyperscalers, AWS, Azure, GCP. It's coming in from Salesforce, Dynamics, all those SaaS applications. It's coming from on-premises environments, file shares, ERP systems. It's coming from sensors and connected devices like your Echo. Just going by my own house, I've got Echoes, I've got Ring doorbell, I've got a connected garage door opener. All of those things have data that is flowing from them. How often my garage door opens, who has been, what motion there's been in my front yard or my backyard or at my door. What is being heard from my house. I'm sure my Echo device could probably tell me when my dog is barked. But all of that data needs to be is all raw at its main form. So we need to look at how we need to ingest that data, and we need to do something with that data that provides us with information. Whether that's sales information, whether that's supply chain and inventory information, whether it's delivery information of where a delivery truck is. That is all pieces that we need to understand and visualize at the end of the data analysis process and processing. So, we take that raw data, we process and clean that data, and then we are visualizing that data, whether that's Power BI or different queries. And this is really that load that ingest that extract, transform, and load process. It's not cleaning and transforming all of that data. It's just getting what it needs to show it to others. And within that processing, we have then the ability to model that information and use cognitive services and other tools to mold that information and get information that is going to serve a certain purpose. I'll use an example of that everybody can probably relate to. That it was really interesting. I'm in Michigan. Pfizer's in Michigan, and Pfizer created the COVID-19 vaccine. The original COVID-19 vaccine required to be kept at a very cold temperature. Initially, it's been adjusted since then that it doesn't have to be as cold anymore. But they essentially had to ship these vials of the vaccine in dry ice. So to do that, They put them in these coolers, in these styrofoam containers wrapped in foil, wrapped in foil bags. But the important thing, and then they put them on these cooled trucks that then had to truck this all over the United States. And for those that were shipping across the world, they had to go into planes that had coolers in them. So how do you know that it maintained that temperature from point A to point B? And what they did was they had a what looked like just a piece of paper on it that had a circuit board on it that was reading that temperature, and that temperature reader had an RFID on it, where it and had wireless technology where it was able to take that data and push that data uh, to an alert, and within within that truck or within that airplane. And when it did that, if there was an alert that the temperature had dropped, it's going to set off alarms. It's going to and it sends that information to the dashboard of the operations center at Pfizer, so that they know that that this vial or this cooler has been compromised, and depending on maybe how long this stays at this temperature, they know to address it immediately, or we might lose 100 vials of the vaccine. So that's using that data, using that information. It's modeling that data and constantly reviewing it, and then it's recognizing certain parameters, utilizing things like utilizing machine learning models and artificial intelligence, and then sending that data, sending those alerts, and then allowing us as human beings to interact and know how to adjust that. Take that a step further. If you're looking at a cooling truck and something like that takes place, we could use machine learning and AI to maybe adjust that temperature, or find out or identify where the problem is in the cooling system that we can then repair rather quickly and avoid damaging sensitive products. So, and I've kind of alluded to this already, but cloud platforms help, and Azure machine learning gives us that ability to take all of this data, give us a place for all of this data, and at a much lower cost than buying very large data lakes and data repositories in our own on-premises environment. We can do that all in the cloud. Running machine learning models and AI needs a lot of compute power, and the capabilities within Azure machine learning, cognitive services, and AI all have that capability. Obviously, they have unlimited processing power. So so utilizing the Azure resources and Microsoft resources, and those of the hyperscalers, give us a very easy point of entry to start doing this on our own. Some things in common workloads within the Azure cognitive services is, like I said, the machine learning, anomaly detection. We'll talk about this in a few minutes around how that can be used from a security perspective and a behavioral perspective. Computer vision, understanding and doing analysis on videos and cameras and images. The natural language processing, being able to have conversational bots and conversational agents, as well as interpreting written and spoken language, and maybe even doing language translation as well. All give us the ability then for scalable and reliable platforms. Like I said, data storage, the compute, all of those services that are needed that really are very costly when you're running, terabytes or petabytes of data through systems and through machine learning models. You need a lot of compute power, and Azure provides that to you. And then the bot services obviously having conversational capabilities through many different channels and different services like Teams and through email and those type of things. The cognitive services that can take data and can extract those fields, enrich that pipeline for rich data and rich dashboards. And for some additional examples that we've kind of talked about in terms of your Azure subscription, obviously, cloud-based machine learning is huge. We have our Azure subscription where we can create a machine learning workspace that ingests that data, has all the compute engines. There's actually some templates for experiments and models that we can create. It's all really a graphical interface as well, and allows us to take that information and model that information, take supply chain data, supply data through a data pipeline, and then model that data and transform that data for proper loading into like a Power BI dashboard. Like I said, training that data, the visual tools that are available are very helpful to run different models and test those models and make sure that we can normalize that data, which is really important when we're trying to figure out somebody's potential for, as this model kind of shows and suggests, if somebody is understanding, looking at data and finding out if somebody has a possible genetic trait that might cause cause them to become diabetic later on in life. Those type of things are all things that we can do with the machine learning and testing data with the machine learning designer. For law enforcement, utilizing surveillance and understanding the grid, understanding the where potential attacks or potential where potential thefts might take place, or assault and battery situations, finding where that is, and then also then utilizing that technology that's around metropolitan areas, as well as even some urban towns, that we can find that data and we can track the steps of that person or people or whoever it is. And with that, we can then do a lot of identification. We can identify somebody's license plate. We can identify the color of their vehicle. We can identify, hopefully with a level of confidence, the recognition, their facial features to identify who potentially could be there, as well as optical character recognition, so that you can get landmarks and understand potential landmarks. Are all pieces there, and pieces of those services of where we can get really detailed here and see that somebody's wearing jeans, or even estimate the age of that person, which is better than I can do a lot of times. 10,000 predefined classes for object detection within computer vision. So this can really help in terms of understanding who somebody, what somebody is, and who they are, and hopefully maybe if it, from a law enforcement perspective, if they committed some sort of theft, we can identify them. Utilizing it within Azure, the computer vision service does all of that. Can do brand detection if you're trying to identify from a food perspective what something is. I've seen this used very helpfully in some mock-ups for menu, from a health perspective, for reading a menu and identifying possible allergens on that menu. Which is an excellent aspect of that they can, being able to take a picture of that menu, and it immediately evaluates the fact that these particular foods might have a particular allergen in them that you might need to avoid, whether you're anti-glycemic or diabetic, or even have like a peanut allergy and things like that. Facial recognition and understanding emotions are all parts of the facial recognition service. Again, locating and creating lists, not necessarily something that's that's helpful from a standpoint of law enforcement, but could be helpful in terms of maybe recognizing a doctor's writing on a prescription and being able to interpret that to send that digitally to a pharmacy. Some custom insights that it can do as well in terms of brands and animated characters. But what I wanted to finish off on in this conversation is so machine learning and ingestion of data and AI and all of the those capabilities are really helpful for for certain especially certain service oriented organizations. So I pointed out healthcare and police law enforcement as kind of two really key ones, but also just from a standpoint of security and governance and security operations, machine learning and AI are an important key that can help organizations protect their people, protect their data, and protect their infrastructure. So, and how do we do that? First off, attackers use AI and machine learning on their own as well. I mean, generally it's bots that are sending some sort of distributed denial service attack. They're also involved in obviously IoT botnet attacks, brute force dictionary attacks as well. Somebody initiates some code and then those bots are out trying to hack into port 3389 or port 22 on your devices. Mutating software, malware, social engineering, finding and detecting some level of common behavior can be done with utilizing machine learning models and AI. Data manipulation and vulnerability identification all are ways that attackers can utilize machine learning technologies and AI bots to help them execute attacks. So why don't we use AI and ML? And we do. So what can it do for us, and how can it benefit us? If you're a security practitioner, security engineer, we can use it to analyze our endpoints, detect that malicious activity that stops those other attacks, and analyzes what is true human behavior and finding anomalies. Automate different repetitive tasks to help us to respond to a threat quicker are all things that we can do. Detecting those zero-day vulnerabilities. Microsoft has their threat intelligence and their threat analytics that are constantly analyzing on a global level and trying to find within your Azure environment potential zero-day threats and zero-day vulnerabilities that you're on, as well as all the building in automation based on triggers that are initiated by something that is found through AI and machine learning models. Some things, and back kind of to the beginning when I was talking about the challenges of AI and ML, is it's only good as the human being that is utilizing it or designing it or engineering it. So what machine learning and AI cannot do is it does not it's not going to do well if somebody's socially engineered. So okay, you have conditional access policies in place, you have multi-factor authentication, but somebody takes a call that's perceived from their IT department, and that our IT department says, hey, I need access to your system, I need your password, and then I need you to give me your one-time passcode that's sent through your MFA so that I can get onto your system. That's a man-in-the-middle attack. That's phishing and spear phishing again. Somebody that's going to click on a link to because they receive an email from Amazon, supposedly from Amazon, that their account has been hacked, not doing their due diligence and due care. So you need a level of planning, and obviously planning and education around security, again, and around development of machine learning and AI technologies. And finally, some of the Microsoft solutions for that are utilize machine learning and AI. Microsoft Sentinel is very rich in that, doing deep levels of risk analysis and behavioral analysis. Defender for Cloud, Microsoft 365 Defender, as well as Azure AD Identity Protection, all utilize some level of artificial intelligence and machine learning to understand potential anomalous behavior that's taking place within those those infrastructures and those services to help you protect yourself. And one of the key things, and this was something that was mentioned by the security team at Ignite, is artificial intelligence and machine learning can help to bridge the skills gap within your security operations that might not be completely cloud ready for security within your environment. The automation and the capabilities of reviewing activity and logs that are taking place within your environment and then alerting on that anomalous behavior is all very helpful to making for a more efficient security operations. And some of the some things that identity protection does helps to protect against those brute force types of attacks, those dictionary attacks, by analyzing sign-in risk and user risk all through that behavior analysis. Sentinel looks for data anomalies, identity anomalies, user and entity behavior, full analysis. The workbooks look for and graph out potential behaviors that are and potential activities that are no longer that are suspect. Defender for Cloud, has their threat intelligence all and identifies those risks and workload protections, and finds common attack vectors based on, again, common behaviors and modeling common behaviors versus potential anomalous behaviors that need to be further investigated. Defender for Cloud Apps helps for insider risk management, finding that somebody inside's doing levels of downloads and deletions, again analyzing behavior, discovering shadow IT, and policies around access and sessions. So that gets us, that really, in summary, we went through quite a bit of information here in the last 40 minutes or so, but we covered a lot of concepts, and hopefully you've gained a lot of knowledge around how machine learning and AI within the cloud helps us with data analytics, data analysis, event and activity analysis that can be used for analyzing information that is coming in through our infrastructure for anything from sensors to potential health concerns to potential public security concerns and public safety concerns, and then also from a standpoint of from a cloud security perspective, how machine learning and AI can help. So that is all. Feel free to reach out. I do have do some blogging every once in a while. I haven't been really good about it the last few months, but plan on getting more onto that. Feel free to follow me on LinkedIn as well as Twitter at the links provided. Happy to hear feedback or have any questions that you might have.
And just in case, if anybody's a little shy about the recording, I am going to stop the recording. I know some people don't like to ask questions on recording.